All right. It looks like we are live on Twitter. Checking YouTube. We're live on YouTube. And let me LinkedIn. I always forget about LinkedIn. It's the problem child. But we should be live on LinkedIn as well. If I didn't mess up the integration again. Shashank, it's good to see you. Excited
Hello,
for our
hello.
third episode of the OpenRouter Show. Super exciting.
Yeah, so exciting to be here. It's been really fun. I think it's forced us to think a lot more about the product so that we know what we'll be sharing with everyone. And yeah, just excited to be here.
Sweet. Yeah. So a couple of things to start off the episode. Obviously this is a live show, so bear with us for some of the bits and bobs and the nuances of running a show like this. For those of you in the audience, we'd love to see some of your questions and your chatter, but please make sure to keep it respectful both to us and our guests. And yeah, we're really looking forward to hopefully a pretty technical and interesting episode featuring some folks from Flex. But before we get to that, as normal, we'll start off the episode talking a little bit about OpenRouter, some of the product updates that we have to share, as well as some really fun new reports that just came out. But before we get into that, Shashank, how about you lead us through some of the product updates that are
Yeah,
really exciting, to be honest?
yeah. Thanks, Tomas. Really excited. And even before I say that what we're building, I wanted to give even one level meta overview of how we think of OpenRouter. And so far, OpenRouter has been positioned as an AI marketplace where it's the easiest way to go get any LLM model that you want to use from any lab. But as we have seen developers use the platform, there are a lot of other features that we feel are really important for an AI primitive so that users can really build very easily on top of the models and make sure that they can have a really good product. So at OpenRouter, we're trying to solve not just the gateway problem, but also a lot of those frictions and paper cuts that users have. So stay tuned for more stuff that comes along those lines, and let us know if there are things that you wish OpenRouter did for you as you build an AI. But the feature I wanted to announce today is broadcasts. Broadcast is now live. It is public. It's still beta because we're still testing a few rough edges, but it works. We have our first few partners, Langfuse, Brain Trust, S3, Vive, in general, any hotel um, endpoint as well. And it's really simple. It's like 2 clicks to set it up in the UI. It's going to be at openrouter.ai/settings/broadcast. You can just go in there, set up any of the providers that we have. There's about 20 other providers that are going to be coming in fast follows. And then, yeah, once you have it set up, you set a sampling rate, and any requests that you send to OpenRouter start getting into the broadcast location.
I was going to say, I think you got a little bit ahead of yourself. We have a new feature called Broadcast. What does it actually do? Why is this relevant to our end users?
Great question. Yeah, I did. Yeah, I'm so excited. I guess I forgot to mention what it actually does. It basically is a telemetry um, pipeline, or it's a tracing pipeline. So when you are sending traces, you're using OpenRouter, generating content using prompts. It's very hard to actually get an insight into what's going on. Is it working? Is the agent replying correctly? Like, what kind of prompts are you getting? And in production, when you're launching these apps, without insight, it's really hard to improve your prompts and improve your product without knowing what's going on. So broadcast allows you to send your prompts and completions into any of these telemetry operators, into the observability pipelines, so that you can see what prompts you're sending, what completions you're getting, and then also build eval sets on top of them. Anything I missed, Tomas?
No, I think that's a great point. Even more condensed version of that is you can now store all of your own prompts and completions without having to write any code on your end. You let us do the job of sending your data to the place that you want it to go, whether that's an existing integration you already have or a new product that you wanted to try out, but didn't necessarily have the engineering time or capacity to implement something like a observability endpoint or a sync. You
Yeah.
give us an API key and we do all that for you without adding latency to your request, without you know worsening performance in any way. So should be
Yeah,
quite a powerful feature.
exactly. And I think, Tomas, we have something other that's super secret. Uh,
I
yes.
am so excited about this. I think internally the team has been stoked about this. Obviously, Claude Code has been a major breakthrough in agentic coding and agentic usefulness. And the main caveat there is that it is an Anthropic platform. They use the Anthropic API. So OpenRouter, being known as the unified OpenAI compatible provider, didn't quite fit the bill. So we're really excited to release in kind of a closed beta, an undocumented beta for now, soon to be more public, a fully compatible Anthropic V1 messages API. What that means is any app, any code, anything like Claude Code that uses the Anthropic platform, the Anthropic API, will now natively work with OpenRouter. All it takes is changing a couple of environmental variables, your base URL and your API key, to use OpenRouter instead. And you can now natively use Claude Code without any proxies, without any kind of extra steps. You just set it up to use the base URL, and you are now interacting with Claude with any of our models. This is not only Anthropic models through OpenRouter. This is, you want to use GPT-5 in Claude Code, you want to use DeepSeek, you want to use the new Mistral models, whatever you want to use will now function in Claude Code. So super exciting, and shout out to our internal team members who wanted to use Claude Code so much that they made this happen through OpenRouter.
Tomas, you mentioned that you have to update some environment variables to use Claude Code.
Yeah.
Uh,
For reference, Anthropic underscore base underscore URL and Anthropic underscore auth underscore token are the two main environmental variables you'd change. And that's just use our base URL, openrouter.ai/API, and then our authentication token, the API key you get from OpenRouter. And
yep.
then Claude Code just works.
Yeah, it's the same if you've used OpenRouter in the OpenAI SDK, just change the base URL and API key. Same concept. You can use the Anthropic SDK. You can use Claude Code.
You can use the
Or
Claude
any,
Code SDK.
yeah, exactly. So big, Tomas. I'm so excited that we finally have this. We've wanted to get it for a while, but as you can imagine, just a new API shape and making sure that we're doing everything we can to make sure that it works perfectly takes some time.
Yeah, and we're not intending to stop there. There are, of course, other proprietary API shapes like Gemini generate content. You can imagine these will also be on the table, and we'll work to get those out for everybody to use shortly with the same promises: unified API, all of our models, all of the endpoints. Yeah, super exciting. We're no
Yeah.
longer stuck to the OpenAI shape, and I think that opens up a lot of possibilities.
And I mean, I think it also goes to show just like how OpenRouter is maturing as a company. We're growing internally in team size, in the APIs we support, and also in how we're engaging with our community, which includes this podcast, but also the State of AI report that we launched yesterday in partnership with A16Z. It is it details a lot of the different learnings and data insights that we're able to pull from serving over 100 trillion tokens since the inception of OpenRouter. And I think there's some really cool insights. One of the first ones that I just wanted to mention is the rise of agentic AI and reasoning models. And I think they kind of go hand in hand. The first thing is that O1 came out just at the beginning of last year. And less than a year from then, we've seen a rapid increase in the amount of models that are reasoning models and the tokens that are generated on them. So over 50% of the tokens that are now generated on OpenRouter are from reasoning models. And
Yeah,
then, yeah,
it's the trends that the report covers are really quite insane. And I mean, fortunately, OpenRouter has been pretty transparent about this data, so it was very possible to like come up with some of these conclusions yourselves. But the fact that they are now synthesized and kind of enriched with some of the other data that we have internally, that the team at A16Z and Justin on our end work diligently to kind of combine and distill into just like pure alpha is really quite insane. One of the things that I thought was super interesting as like a learning is this kind of glass slipper effect. And I think it's one of the terms that kind of caught on, and I see people picking it up in the discussions that are coming up on X and across some other platforms. Can you tell us what this is? It sounds like a Cinderella story. Like, what do we mean when we say glass slipper effect of the models?
Yeah, I think the team did a really great job of coming up with a viral moment for this one. But it is like one of those things that was truly novel, even for us as we were building the report. It wasn't something that we'd really thought about when we were going in. But when you're looking at cohort retention, and what that means is if you were to take the month that someone tried the model in and then see where like did those people that started in month one, did they stay on in month two, in month three, month four, and then you do this across months for the cohorts. Something that we noticed is that the early adopter or the people that tried the model for the first time also had the highest retention rate. And that the reason we're calling this the glass slipper is because a lot of times people have use cases that they've been trying to solve and they haven't been able to like get the right model to solve that use case, and then new model drops. They try that new model and the slipper fits, and it fits perfectly, so they just stick with the model because they're like, this thing works. And once we what we're seeing is that once you have a production use case, like you have a workload to model fit, people actually are very sticky. And it is a really good sign for model makers. So, for example, especially for Gemini 2.5 and Claude 4, you can see this scenario, like a phenomenon, very, very clearly. And for both of those models, they were like actual leaps in the model capability, and you can see that. So people are like price inelastic, but they're sticking even as newer models are dropping. And on the flip side, with Gemini 2 and Llama 4, you actually see that there wasn't a first cohort that was able to find a workload fit. And so because of that, their retention across the board was really poor. There weren't people. And then you kind of get to see that month over month. Um, if you don't have that initial adoption, it's really hard to build momentum. Uh, yeah.
Yeah.
But really cool stuff. Lots of other insights. Would definitely recommend checking it out. Even just like on Twitter, there's a few different resources that have more data, and we'll try and do like kind of a little bit of more of a breakdown. Um, but yeah, any other stats that you wanted to point out that were exciting, Tomas?
I think I, I feel like we could spend a whole episode on this, and we may
Yeah,
even do that. Invite some of the folks from A16Z in to chat about it, because there's been a ton of reports like it. But I mean, 100 trillion tokens is hard to beat. So
yeah,
before we like get rabbit holed on that, one of the
exactly.
trends that I am excited about that isn't quite captured in the report this year, but could be next year, is the trend, of course, of image models. We recently had Nano Banana come on the platform, and then we did work to bring a GPT image styled Nano Banana experience. And most recently, we've had Black Forest Labs Flux 2 models on the platform. So we think this is going to be a really compelling use case. We're already seeing usage just skyrocket. The trend is quite obvious. So we're really excited to introduce our guest for today, Robin Robmach, from Black Forest Labs, CEO and co-founder. Robin, so good to see you.
Hey guys.
Good to have you. Hey.
Hey, Robin, welcome to
Hey.
the show.
Hey. Thanks for having me.
So we'll kick this off. I'm going to give Robin a bit of an intro here for our audience. If you look up Robin, you're going to see mostly like paper citations, not necessarily like a super public CEO, but obviously a very legitimate academic. So props to you and your team. You guys at BFL, you're a team that comes from an academic background. You're quite naturally like rigorous researchers, and from my understanding, continue today to be a relatively small and focused team. But for context for the audience, the team at Black Forest Lab was the ones that were like co-authors and co-creators of the stable diffusion models, stable diffusion architectures. And kind of where that started was being in a team and being in a region that was more compute constrained. So you guys really focused on efficiency and came up with this idea of, you know, latent diffusion. How do we get these models to compress images down to representations that are actually usable and able to be processed in a not cost prohibitive way? That's how you get to stable diffusion. We fast forward a bit and we get to Black Forest Labs, your new lab, your new company, again, with the same core people, as my understanding, the same core researchers, where you come up with your, rectified flow transformer, which I think is just the coolest name for like any of these architectures. Rectified flow transformer. This is a shift away from latent diffusion. We get closer to the more LLM-based transformer architecture, but you are also continuing to focus on efficiency. And these are faster, smarter, better prompt adherence models. So with all that being said, Robin, I'd love to let you speak a little bit about your own background, your own intro, and really speak on what I think is the most impressive thing: this efficiency and compute ability of the Black Forest Lab team.
Yeah, awesome. Thank you. I think you summarized it pretty accurately, actually. First of all, yes, it's true that we co-authored on like stable diffusion. Before that, we actually introduced this work called latent diffusion, which I think is like more of a like core like fundamental concept that unifies the fact that you can compress stuff like natural data, like images are, right, or videos or audio data. You can compress that into like a much lower dimensional representation, which makes it then easier to model. And then it doesn't actually really matter if you choose, like, as we did back then, a unit-based architecture, or as we do today, a transformer-based architecture. In the end, the whole paradigm is just, I think, like more general than that, and still very valid, right? It's more about like coupling these two different stages together. And that's, I think, like one of the core, basically, insights, which makes these models more efficient. It makes them more efficient to train. There's a bunch of like new exciting work that we also incorporated into like the Flux2 development and the Flux2 model that we just recently released that makes the training much faster. I'm talking about works like Rapper, for example, which is currently a very popular technique. I think then the other aspect is also really make these models not only efficient to train, but also efficient at inference. The latent space compression really helps with that. But then in diffusion models or in flow matching models, typically evaluate like on the whole sequence of tokens again and again. So there's especially for like long context models, there's stuff that you can think about around like context caching that you have to train into the model, which is a little bit different than in language models. But also just distillation and making like the denoising process faster is something that we have specialized in quite a bit. And yeah, then results in pretty efficient models actually that you can run quite cheaply.
Would love to also figure out how do you think about diffusion models versus autoregressive models when it comes to images? Because as you mentioned, there's like some efficiency there, but yeah.
It's a whole religious debate sometimes. There's like an interpretation of diffusion models are autoregressive models in frequency space. So you can actually look at it from that perspective. But I think that like the core principle is, I guess, like you either work on a series of tokens. In the simplest case, it's like discretized, and you train like the vanilla LLM type of approach, the autoregressive approach. That works surprisingly well. It works maybe even better than you would assume for stuff like 2D data, like images, because lots of people argue that it's quite unnatural to roll an image out in a 1D sequence, which I think there's like a lot of like intuitive pushback against such an approach. But then on the other hand, you just know that it works, right? And there's a lot of infrastructure that is currently being developed around these models, obviously, which helps quite a lot when you go down that route. Diffusion models, on the other hand, they work really well naturally with like continuous spaces, like the VAE spaces that we have been designing in the past, and provide a bit of a like out of the box higher perceptual signal, higher quality outputs, and also don't have that weird unrolling constraint, basically.
Yeah.
And I think they are like, just from like a pure model design perspective, they're like perfectly made for natural data like images.
Is there a difference in world understanding between the two, or not really?
I think there's a difference in training efficiency, how much data these models can eat during training. Also a bunch of papers on that were recently published. I think to a certain degree, text in itself is like already like a more compressed representation, so it's a bit more like simpler to absorb like a lot of world knowledge with autoregressive training. But then I guess like exciting applications are when you actually combine these two approaches, potentially combine like autoregressive text modeling and diffusion modeling, flow modeling on continuous tokens.
So speaking about text models a little bit, one of the things that surprised me about the blog reports, and I don't think that is necessarily actively being discussed all that much, is the fact that you did end up using Mistral 3 24B as like your text encoder within Flux 2. First of all, like, how does that work? And second of all, how do you end up picking, obviously you have a partnership with Mistral, your models power their image generation in Le Chat. So there's this really strong bond there with these two massive EU labs, but that fact was kind of surprising to me. So I'd love to understand more about, you noticed some kind of weakness here and you decided to go this route. Is that kind of how that played out?
Yeah, so if you look at like the open source models that have been available before, I don't know, this year, a lot of them were using like a pretty ancient, old text encoding model called T5, which works surprisingly well if you combine it with diffusion decoders, right? But I think, at some point it was time to look into more modern text encoders that don't have like certain tokenization problems that are important if you think about applications such as text rendering that are able to natively handle like more languages than English, or also like non-Latin English languages. And I think that's like few of the motivations that we had, besides pumping a bit more world knowledge into the text encoder that's actually coupled to the flow model, to the diffusion model. And we then like looked at a bunch of different models actually, and at the time found that this combination of models works best for us.
Awesome. Yeah. And is this something that you guys only started doing for Flux 2, or were you doing this before as well?
So the Flux 1 dev model that is publicly available, that is using a T5 encoder still.
Okay.
I was also a little bit surprised that like 24B is not a massive model these days, but it is a dense model. It's not an MOE. Were there, like we spoke about efficiency earlier, how do you kind of compare that risk, so to speak? Were you considering something like a Gemma 3B at any period, or was it just like there was some level of quality and prompt adherence that we really wanted to go for, and you tried to find the smallest possible model to fit that bill? What does that look like?
Yes, it's a very good question. I think in general, when we work on designing these models, we always want to hit the right balance between like quality, reliability, but also efficiency. For us, that like the Mistral model that we are now using, given also like the diffusion model size, hit the right like trade-off.
Right.
I think when you look at like more efficient models, we also hinted at the fact that we're going to release a distilled version of Flux 2, Flux Klein. Then you'll likely end up with like smaller text encoders. Let's put it that way. Because then you have like, otherwise you have like kind of a weird imbalance between like a super, I mean, as you said, 24B is not giant, right? But in comparison to like the diffusion model size, it would be kind of big.
Does it matter? Like, do you guys also deploy your models like on device or on like hardware that is like very compute constrained today, or is it mostly like on servers that you guys are hosting?
So around like the earlier models, and I found this like very exciting actually even after like the stable diffusion release, right? Like when people started trying to run, I don't know, stable diffusion 1 point something on like an iPhone, and I saw like the first output, and I think it took like 10 or 20 minutes or what, I don't know, to render like one image, but it was like insane. Yeah, since then I think this has like improved massively. I find this like personally very exciting deployment opportunity. As a startup working in the space, you kind of always have to balance like all of these different like potential deployment options that you have. We kind of we all think about that from like, okay, let's make it work on classic GPUs first, and then see if we, or like actually on the open source models, the online community is faster in developing something for on device. But in general, it's super exciting.
Awesome.
If I remember correctly, I believe I saw Schnell running on device a few years back as well. So like Klein hopefully continues that that innovation and that excitement within the open source community to get like good quants of the model available, that kind of thing.
Yeah.
One of the questions I had was around Flux 2, and we're very excited because we have Flux 2 on OpenRouter, and we've seen really great adoption, very good use cases. People are starting to like, I think we're seeing tens of thousands of images being generated every day, which is very exciting. But wanted to like get the inside scoop for you guys. Like, what was the training process like? Were there like, have the architectures continued to scale in the way that you expected? Was there anything emergent that came that was maybe like you weren't expecting the model to be good at? Or like, what was like some of the mindset shifts as you were like training new models?
Yep. I think in general, Flux 2 behaves a little bit more like a hybrid between, I mean, obviously it produces images as the output domain, right? But it feels a little bit like LLME, I would say. And I think that's like different from like more like the prior classic diffusion models. Also needs to like, as a user, you basically need to, me as a user of the model, I needed to change like the prompting style or like how I interact with the model, but it now also has like this extended context window, right? And we were pretty explicit about like we wanted to add like more images into the context window for it to have like this ability of combining multiple images into like an output based on a text instruction, something that is like net new. I find like on emerging capabilities, what I find like really impressive is actually like this kind of, intelligent rendering when it comes to text placement. So when you can input an image and say, turn this into a meme, and then it actually gets the text placement kind of right a lot of times, and that's something that I find like really nice, or like line breaks, or depending on like the output resolution that you choose. And yeah, this in particular is like one application that I thought, oh wow, this is actually nice.
One of the things,
great application.
Oh
Sorry.
yeah, Soda application generating memes. One of the things that OpenRouter co-founder Louis Vicky found when he was playing with your model was he prompted it like a text model with a screenshot of Slack of one of our coworkers saying, "Oh, what model is that?" Like not realizing what we were talking about. And it said the prompt was just introduce yourself and a screenshot of Slack with somebody saying, "What model is that?" And Flux was able to generate a text response through the image as if it had replied on Slack. And that is like not something that is obvious that it would be able to do, to like position the text in the right box. If it was a reply, introduce itself in legible text in like small font in the Slack interface. And like it definitely behaves more like an LLM, just only constrained to image output. And so along that line, what we think about at OpenRouter being kind of more of an LLM platform is there a way to get your API in its shape today to behave more like a Nano Banana or like multi-turn chat experience? So one of the things that we're experimenting with is, can we build our own chat template that will merge multi-turn messages and multiple input images from different turns into just like a native chat experience? Because like you said, you have up to 10 reference images. You have this huge like 45,000 token context window on the input. There might be some way, and maybe this is something you're experimenting with, maybe not, but it feels like there could be some emergence here of just in its current state, without you having to build more into it, a way to do like a chat multi-turn interface. And so I'm curious, is that a use case you guys are building towards, thinking about? Like, does this surprise you, I guess, to hear?
It doesn't, like, to answer the last question, it doesn't surprise me. Like, we've been playing with a bunch of like these I don't know, simulated chat interfaces internally where we just sampling with the model. I do think like on the more like chat or multi-turn interface more generally, we're thinking about this quite a lot as well. I think even, or like maybe more in the context of, I think the topic of generative UIs itself is kind of hot now, and I think will be even hotter in the future. And that's something that I'm myself like also very, very excited about. And thinking about it in that way, not necessarily coupled to the chat interface, but how do I actually give like the model a persistent memory state? How do I give it like a, this context window, or however you want to call it, where you're able to cache the previous conversations and basically be able to go back to like an earlier output. It's more, I think about it more like in terms of like a fluid UI.
Yeah, like an iterative, like branching kind of thing where you continue building off a thing, or you can go back and try something else, and you have this conversation state stored.
But I do think it should actually already be possible to emulate like a chat kind of interface with the current model.
I mean, that's how it's implemented on OpenRouter today. So people just use the chat completions API that they're already used to, and then they can use generate images or edit images. A meta question I had around like this fluidity is, at BFL, are you guys seeing more like true image generation cases where it's just a text prompt into image, like the Mid-Journey stable diff, like that kind of workflow, or are we seeing more like reference image, something like image editing versus image generation, basically?
Yeah, good question. Image editing itself, I mean, I would say it just started to work properly this year. We had like a few models that have been released, like GPT image one, like then our own Flux context model, I think, was the first one that really hit like character consistency, and now it's like a real thing, right? Like it's such a massive use case, and it makes sense to me, like especially when you're able to make edits really fast based on a text instruction, and actually also able to combine like multiple inputs. It just like feels even to me, especially like the multi-input merging, like a magical experience. But the utility of that is also really high, and we see that internally. Like image editing itself is such a massive application. I would say it's even like larger than pure text image generation.
Yeah, and I think the character consistency that you mentioned is so key as well. I think the whole reason that we had like the Studio Ghibli moment was because it felt like it was the first model that was able to keep, like, you could recognize the person even as it was Ghiblifying them. And we've obviously now seen with Flux 2, it's like at a whole different level where you can even have like realistic, like people will look like them. It's not as cartoony, but yeah, you can keep the same character through different backgrounds, different actions, and it's starting to get really uncanny, to be honest. Yeah.
It should be beyond the uncanny valley already.
Yeah, it definitely is.
Yeah, for sure. Internally, sometimes people will just drop an AI edited like image of one of our own coworkers, and like it's very, very funny. And then once you're done laughing, you're like, "That's weird," and then you just kind of have to move on with your life because this is just everywhere now. Like the Gemini app has this for everybody in the consumer space. So yeah, super interesting and super excited. Speaking of things that are coming in the future, we kind of want to end this section off with, I'm going to kind of pick apart some of the stuff you said in one of your recent interviews. You mentioned a lot of other modalities, right? We're talking about Nano Banana. We're talking about teams like Minimax out in China, who are these big research labs akin to Google that are creating models in every modality in every specialized instance, right? You have things like Sora, that is probably something transformer based, that is doing text and image, and actually, sorry, text and video is the input to Sora, considering your Cameo is a video and audio of your voice. And then you get out of Sora something that's more like a world model output, where you have physics, you have a character, you have audio. And so like the combination, or like the work that all these labs are doing to combine outputs into these big general models. My question to you is, as a lab who has done both specialized models, and now Flux that is kind of more of a general model, right? You used to have image editing was one model, image generation was a different model in the Flux 1 era. You've now kind of combined those into Flux 2. Going forward into other modalities like video, like audio, whether that be speech or music or whatever. Does Black Forest Lab think it makes sense to go the generalized route first, or should we expect something more specialized before you get to these like crazy world models?
There's a lot in that question. I think in general we are at a point where tasks like image generation, they will benefit from a model that is being trained at least as like an auxiliary task on other modalities as well, like you mentioned text, for example, right? I think we as a lab will also follow that route. I'm like extremely excited about the potential of real-time world models, or like real-time video generation, to put it like very like simple, right?
Sure.
Especially in this context of generative fluid UIs. I think that's one application that I think in the future is going to be massive and transforming potentially a lot of the existing stuff. Then I guess there's also like all of this like robotics applications that are currently seem like a little bit far away, but I actually don't think they are that far away. Like using these models to simulate and train other agents in them. I think in general, we as a lab will, as I said, like over time add like modalities. I think it's quite natural if you actually look at like the evolvement or like the evolution of these models. Text, like simple text in, image out was kind of the first thing, has expanded into text plus single image in, image out. Now you have like multiple images in, text in, image out. It's moving into like more stuff in, more stuff out. These models, they are then kind of like these generalist models are kind of like heavy and growing. And I think it remains like important to derive specialized slices from these models. But again, I think like their generalist pre-training probably helps them to be better teachers for like more like specialized, let's say, distillations or students that you derive from this general models.
Is there like a MOE kind of world for image models as well?
Not sure if I would call it MOE, but it's more like unifying actually a bunch of tasks and potentially benefiting from transfer learning. Although that is like a topic that needs more exploration, I guess.
Instead of a MOE where it's like all experts in one architecture, it could just be something more akin to like a model router is maybe what we're getting at, where you have a bunch of specialized models handling different inputs and different outputs.
Yes, on the one hand, that is something that I guess could happen on the more efficient side.
Right.
And you need to have like some orchestration between these specialists. But I think and that's like the efficient end of the spectrum. But then you also have like the generalist end of the spectrum, where all of that is basically within like the neural network world.
Like a Sora.
Neural network weights. Yeah, exactly. Like beyond that. Yeah.
Right.
All right.
But I guess like then like the interesting challenges are actually in, okay, now I have like this model that runs on a super long sequence. How do I make this like 2 orders of magnitude faster than the stuff that we have today? I think this is something that's completely non-trivial and like an exciting area of research.
Yeah, for sure.
I mean, we trust you guys to figure this out. You guys have been
no pressure.
No, but it's been awesome to have you. Thank you so much, Robin. I learned a lot about image models, and I'm sure the audience enjoyed as well.
Awesome. Thank you.
Thank you so much, Robin.
Yeah. Thanks, Robin.
Bye.
Bye.
That was so cool. I don't know if also people picked up on what he was saying about like fluid UIs. What he's mentioning is you are browsing a website and the UI is being generated in real time as you use it.
he mentions it and it becomes obvious that that is a functionality that is going to be transformative of like real-time video generation models. But before that got mentioned, that did not seem like a use case that would have ever have
Yeah.
come up. Like I don't think I ever would have thought of that. And now it's like, oh yeah, of course.
Yeah.
Like
I mean, and then once you start thinking about it, I was like, wait, but like, can you do video games? Can you like generate the game as you play it?
yeah,
Like
Genie
actually,
3, the Google World model, Genie 3 is basically that, right?
yeah. And I mean, I'm pretty sure we'll get all of these before we get GTA 6. So
Maybe GTA 6 just gets built by a world model and then everything
exactly.
will be fine.
Yeah, that'd be hilarious. But no, I mean, that's everything I had, Tomas. Anything you wanted to add?
I don't think so. This might be one of my favorite. I feel like I just need to take a moment and rewatch what we just talked about because my mind is blown a little bit. Definitely one of my favorite episodes we've done so far. Um, I think let's just give a little product recap because we've
Mhm.
just been dropping so much stuff and we're not done cooking. And then see if there's anybody in the audience that wants to ask questions. Otherwise, we can wrap it up here.
Yeah, awesome. I'll do the product recap. Tomas, why don't you see if there's any questions
Yeah.
we can get to? But yeah, so we mentioned broadcasts at the start. Please go check them out. They're in our docs. They're going to be a really simple way to get more observability for your prompts and completions. There is a super secret alpha of the V1 Messages API. It allows you to just use OpenRouter for your Claude Code and any other Anthropic compatible APIs. There's going to be more API shapes that are coming soon, but just to understand, we have chat completions, responses, and now V1 messages. So that's like really like most of the APIs in the market right now. Then we also have now added a bunch of image models on the platform. We have both of the Nano Bananas, obviously GPT-5 image, Flux 2 Pro, Flux 2 Dev. We're going to be adding some image models from Sourceful, some from Seed, um, so just stay tuned. There's quite a few companies out there, providers and model labs that are working on the forefront here that we want to get to you guys.
I'm so excited about all the work that's going on. The team's scaled up so quickly, and we've got some really awesome folks working on all these different features now. And from everything from our like self-serve devs to our enterprise teams, I'm stoked that OpenRouter is going to get even better as the control plane for all your intelligence needs. So thanks again to everybody for listening. Didn't quite get any questions, but mostly because YouTube live stream is just bad. So bear with us. And of course, join us on Discord for conversations. That's always a great place to ask questions as well. Thanks for tuning in. We may do another episode in December. Otherwise, we will see you guys again in January. These have been a blast. Thanks for having us.
Yeah, thanks for having us. See
Goodbye,
y'all, everybody.
everybody.